plates. So thank you very much for being here, and I'll turn it over to you.
Thank you, David. So hi, everyone. My name is Suthendra. I am the head of data-driven process optimization within the investments organization in AIG. Many of you might know AIG is a large insurance company. What I'm going to talk to you about, before I do that, I just want to throw a disclaimer that our legal department asks us to put on every technical presentation we make outside. And just give a few seconds and then jump right into the content of the talk. So as I said, one of my objectives of my team's objective is to develop process improvement solutions for our business. And as part of doing that, we have developed a methodology which we have branded as Process Wind Tunnel. We think it's a very novel process improvement capability that uses data-driven approaches to improve our business processes. And simulation, discrete event simulation particularly, is a very important component of that of this methodology. We have done numerous projects using this approach and have continually been enhancing and improving the underlying capability. One of the challenges that this talk will center around is how do we enable, let's say, a less skilled person to be able to leverage discrete event simulation capability as effectively? Because as most of the people on this call know, the simulation is a very difficult and requires a lot of training to build good simulation models and interpret them. So let me start with just talking briefly about what this process wind tunnel methodology is. And it's really analogous to wind tunnels that are used to design race cars and aircrafts. I mean, the idea is that you don't just put in a business process and hope it will be optimized over time. You actually build an environment where you can test drive it, optimize it, improve it, run various scenarios, and then launch the business process. So let's say if we have a business process, of course, we start with process mapping. This helps us understand the business process itself, the various activity constraints, the various systems, and the data flows. Once we have that and we gather a lot of data from, let's say, a given process, we use several analytical tools to analyze the process. Three of them I'd like to mention. One is, many of you might be aware of, is called process mining, which has gotten a lot of attention in, I would say, in the last decade. The idea here is that you look at event logs that processes generate, and then from those event logs, you try to get insights into the process. So it's great to look at historical data and try to get insights into what's going on with the business process. So a lot of the work that we do with simulation actually complements that, because if you look at process mining and looking at historical data and analyzing it statistically or doing any kind of predictive analytics, largely it's looking at historical data, right? So it's looking backward. And then once we have established the baseline for the process and we want to figure out how do we improve the process or look at what we call the future state design, that's where simulation plays an important role. And we use AnyLogic for that, because one of the powerful features I like amongst many about AnyLogic is that it allows you to integrate with other tools, through the efficient Java programming capability it has, and some other capabilities. So we like it very much for that reason, one of the reasons. And we use the AnyLogic tool to build data-driven discrete event simulation models, where we build the model, do the scenario analysis, look at new design options, scheduling, and the like, and come up with an optimized or improved design. And then as part of analyzing the process end to end, we may identify areas where either we could do targeted automation or even maybe complete automation, depending on the nature of the process. We also have started looking at the idea of digital twin, because, as I said, we gather so much data from the various systems and that orchestrate these business processes and develop a view of the process that it's important. We have already established a framework for really building a digital twin, which can be used for more continual improvement. So with that background, let me just talk briefly about how discrete event simulation models are built in this environment, right? So as I said earlier, it requires highly skilled individuals in simulation and analytics. Typically, such a person would work with the business process domain expert to understand the process flow activities and their characteristics, which would mean, looking at process maps, different views of the process maps, understanding the task job arrivals of a business process, activity and time resource information, any historical activity or execution data, right? So this is typically done jointly, working with the business process domain expert who may have little or no knowledge about simulation. So it's a partnership. And then once we have gathered all the information, we can go ahead and build the simulation model in AnyLogic. And that's largely done by the modeler. And then once the model has been built, then the modeler and again, the domain expert can either jointly, with largely input from the modeler, utilize the simulation model to perform scenario analysis and optimization. So this is kind of like, at a very high level, the 3 steps that would be taken to build a simulation model. Now, as I said earlier, simulation modeling requires significant information gathering, right? And if you want to look at the information, it's really of 2 classes. One is what I would call, let's say, the topology or the graph structure of the flow. What happens, what decisions are being made, decision blocks, things of that nature, and business rules and constraints, so on and so forth. And the next one is, what I would call more parameter oriented, like the parameters that go into each of the activity blocks in AnyLogic. Now, typically, it's easy to parameterize the second class of work, but the first one, where you have to capture the overall flow and the various constraints, is a little harder to do, right? And within the straightforward way we build models in AnyLogic. So what we typically find, at least in the insurance business and as well as in many other business, I would say, is that a lot of times you look at a class of business process which may have multiple instances. As an example, you may have an underwriting process, but you may have many instances of that depending on the geography, the service type that's it's offering, the staffing levels, the business application schedule. So as you go from one underwriting process to the other, maybe the base structure is similar, but there are variations on top of that. You can think of it in other areas like retail or grocery stores or whatever. I mean, there are many numerous examples where you see a overall structure, but a lot of variations as you go from one instance to the other. And that's really what we are trying to tackle with what I'm talking today, is how can we scale the simulation capability across all these multiple instances. So the way what I'm going to propose here is that we decouple the process of information gathering, which is actually quite time consuming and requires a lot of time from the business or the domain expert, right? And that's where we propose the use of a predefined template. And this template would, of course, have to be dependent on the business process that you're looking at. But we want to develop the template that has information that a business person can understand. So for example, as I said earlier, parameter variations can be easily implemented. However, structural variations are difficult to update automatically. So if you look at a template, what are we trying to capture? We are trying to capture things like arrival information. We are trying to gather activity time distributions. Now, sometimes, you may not have detailed activity time logs from the systems, and that's when you might rely on statistical distributions and parameters. Like a lot of times people use triangular distributions. Then we have to somehow capture the model graph, as I said earlier, the resource schedule, and some business rules. And this template is what we would be providing once we have developed it, customized for that business application. We would enable it so that the business person who really has very little, maybe limited understanding of discrete event simulation technology and modeling can input all that information. And then from that information, we want to generate the AnyLogic discrete event simulations model automatically. So an example of a data collection template, for example, you could put it all in an Excel spreadsheet. You may have a general tab which has some general information about the process. We may have a tab that contains the arrival distribution, and this thing could actually come from either standard distributions, or there could be some non-parametric actual data, or we may have some notion of what are the activities and what are the different types of activities. And as you can see here, I'm showing a triangular distribution. Similarly, we may have the model graph structure, so it tells you what the activities are and what kind of activity it is. So there'll be some level of training, if you might want to call, where you want to probably explain the person what you mean by a service block or a delay block, but they will essentially specify those things. And then perhaps the resource schedule and the number of FTEs and things of that nature. And again, I'm giving you an example from a business process where we applied this approach to. Depending on the different business process, the templates might be different. So once you have this information that typically a modeler would need to build a simulation model, there are two ways of doing that. So AnyLogic recommends that we use their built-in Java functions to programmatically construct the simulation models within the AnyLogic environment, right? So the idea would be that you would write some Java code inside of AnyLogic that would read these Excel templates and then interpret the data and then somehow construct the model, the simulation model automatically. But for that, you have to do it from inside of AnyLogic. The approach that we took was we said, okay, AnyLogic actually reads in what are called the ALP files, which are really XML model files, right? So we said, if we can, from these Excel templates, if we can programmatically write out those ALP files using our Java, some Java code or whatever code you want to use, then we could, once we have the ALP file, then we could import it into AnyLogic and then use all the power of AnyLogic to do the further analysis. So here's the XML code that if you open up an ALP file, you'll see some XML code, right? And that's really what we are trying to output. Now it was a little bit challenging because AnyLogic XML schema is not, I don't think it's published, so we had to kind of re-engineer it by first creating those models and writing out the ALP files, and then from there reverse engineering the AnyLogic XML schema. I think in the future, if the schema is published, then it will make the task more easy. So the idea here was that once we understood all the classes, the Java classes that go into the ALP file and the AnyLogic XML schema, we use the JXB compiler to generate those classes, coupled with the Excel template and those class definitions and the Java application, we were able to write out the XML document. So now if you look at the way the modeling is being done, the business person is only dealing with those Excel spreadsheet, which has information, modeling information, but interpreted in or written in a way that a business person can understand. And then from there onwards, the process of transforming that into a AnyLogic simulation model is done automatically. Now, agreed, for that, we'll have to do the first time, probably you'll have to do it manually and then understand all the constraints and everything. And then you will create this generalized solution. But then once you have this, as you move from one instance of the process to the other, all you're doing is, you're changing the Excel data in the Excel template, as I showed you, or whatever format you want to express the data in. And the modeling part would automatically be taken care of by this application. So just to give you a demo, it's the same spreadsheet that I just talked about. And you can see, it contains all the various information about the model that is used to create the model. And you can see, the various activities were captured working with the business people. And once this template was created, this program was run, and it created the ALP file, which you could read into AnyLogic, and you can run the simulation and start interpreting the output of the model, right? So this is the base case. Now, if let's say you go into another environment where, let's say, some events or some steps are missing, for example, the fill submission form is not there in another process. So you basically eliminate that, and once you have updated your information, you can run the same program, and now you have the new model, right? So all the variations that you potentially would experience are now captured in a very easy to use template. And now what we have done is we have been able to decouple the process of modeling from what I said earlier, and this hopefully will enable us to scale the modeling capability across a wide range of similar applications or similar type of business processes, which still may have a lot of variations as you go from one place to the other. So that's really what I wanted to share today, is this whole idea, because again, if you have an environment where there's just one instance of the process, of course, then you would just build it one time. But I'm talking about the place where we do have the issue of multiple instances of a given process, and you don't want to be spending time, from scratch, building the model over and over again. And what we have done is, we have enabled the full scalability of model from the business information to actual modeling, and even the interpreting of the results can be if we understand really what is the output we are looking at, then we can even provide those standardized outputs so that even that part can be done largely by, let's say, a business person, and not necessarily an advanced AnyLogic modeler. So that's what we have addressed in this talk. We talked about the predefined templates to capture information that can be customized for business domain experts. And then we developed a software to automatically interpret this templatized information and generate the model, as well as standardize the output. And the purpose, as I said earlier, was to enable this capability, what I call the discrete event simulation modeling technology and capability, to be utilized across the business enterprise and not necessarily by a limited number of experts in simulation modeling. So that's really the purpose of this talk. And with that, I'll be happy to take any questions. So there's a question that says, do you have compatibility problems with your generated ALP files when AnyLogic version updates? Yes. And as I said earlier, this would be a good feature request to make to AnyLogic, is to, if possible, publish their XML template so that these changes can be monitored and adopted as the changes are occurring. And even, let's say, we also have a slightly I would say another problem which I briefly alluded to, which is because we don't have the published template, we had to reverse engineer the template by actually creating the model like we normally do in AnyLogic, writing out the ALP files, and then trying to understand the class structure. That's because we just don't have it published. Now, we did go to AnyLogic, and as I said earlier, they recommend doing it from inside their environment. So the short answer is yes. The way things are right now with what's available from AnyLogic and how we've implemented it, there are some of these issues that we have to be aware of as the versions change, and especially if the changes affect the model that we have, the modeling schema that we are using to write out the LP file, then absolutely yes, it could create some challenges. There was another question. What was the problem with using Java to generate the models that made reverse engineering the XML more desirable? So again, the point is that why didn't we just build everything from inside of AnyLogic, right? And why did we have to write out the ALP files? It's really how you want to partition the problem. So remember, the problem you have the business domain expert, then you have the modeler, and the way we wanted to do it was we wanted to decouple the business person completely from the modeling person. Our eventual goal would be to see if we can minimize the role of the modeler as much as possible once the problem has been understood, once the models have been created, right? So to do that, we thought it would be great if we could just have the Excel file, the Java program create the LP file. We could have it AnyLogic automatically run the models, and we know what kind of outputs we are expecting, and we could have AnyLogic write the entire output to something that the business person can understand. And then we have basically created a shell around AnyLogic, and the business person may not even need to go inside or interact with them. So architecturally, it's a different architecture, and that's what we decided to go with. I mean, I'm sure that if you went with the AnyLogic route, you might be able to accomplish something similar also. But it's just that that was really not the focus of this presentation. It's really to bring the awareness that how do we in the problem space that I'm discussing, how do we get past that, and how do we enable the scalability of simulation technology across, let's say, a broader class of people? Okay, so there's another question here. We looked at your approach for a project and determined the programmatic process creation was massively preferable for some reasons you mentioned, and the overheads of regenerating ALP files versus just parameterizing a generic self-constructing model. Are you still happy with that decision in retrospect? I would say that, I mean, we went down this path, and it's something that we have been looking into. As I said, I'm not averse to going inside of any logic and doing things completely programmatically, but this is the one. This is what we approached. This is how we implemented this particular version that I discussed. Could you please delve further into how we could utilize the process data event logs to create simulation models? That's actually a very interesting question, and it's been on the top of my mind for a while. So, as I said earlier, the event logs, the ability to mine event logs, the technology goes by the name of process mining for many of you who may not be aware of it. And there are excellent third-party tools now that are available that can help you visualize and generate process maps from event logs. Now, the ideal, a lot of times, even I was trying to pursue this idea that can we take the event logs and right from the event logs, can we generate a simulation model? So technically you could do that. There are some challenges though. One of them is when you look at an end-to-end business process, because if you look at, let's say, an underwriting process, right? It's not like a self-contained process that's being executed in a single system. So there are multiple diverse business applications that are orchestrating the process. And if you're looking at event logs that come from these different systems, they may be at different levels of granularity. So one system, for example, might give you a very granular log, another may not give you a very granular log. And then if you have to put all of those things together to get an end-to-end log and then automatically try to convert it into a simulation model, it creates a lot of challenges. Secondly, when you're looking at event logs, there are a lot of what I would call decisions which are embedded in simulation models, which you don't get directly from event logs, right? So for example, if you have a simulation model where one action is dependent on some action happening elsewhere, and that a lot of times it happens, right? Now you can build that programmatically once you know what that logic is into your model. And as I said, you can even somehow put into if that's critical, you can even put it into one of your templates. But if you're trying to infer that from just event logs, you might get some probabilistic information, which we oftentimes use. So a lot of times what we do is we use those event logs and process mining to get things like transition probabilities. So like when stuff is coming at a particular node and is going from that node to in different directions, you can probably infer that through these event log analysis, process mining. So process, the way we have used it, again, I'm sure there's more work that needs to be done and more of this technology needs to be developed. The interface between process mining and simulation is we build simulation models based on our understanding of the process, but we augment it significantly with our deeper insights that we get out of the process mining studies. So the combination of two definitely complements each other, but I don't think we are at a point where we can take process mining and directly convert into a simulation model and have something that is very reliable. That's my personal view. Maybe there are some niche applications where you could do that, especially if you don't have a lot of these decision points and things like that I was mentioning. So I would say that yes, they nicely complement each other. As I was listening to a talk from one of the leading vendors of process mining yesterday, and they compared process mining to something like an X-ray, which I think I like the analogy. So it's great to diagnose your process, and we use it wherever we can to get insights into the process. But then when we look at the future state design, I think simulation technology is what we use, and it provides us with much more insights. So how much effort did this take, and was the time saving enough to make it worthwhile? Would you do this for more processes? Again, this will depend on case to case. This is something you'll have to infer based on your own situation, right? Like we created a similar version. So right now I'm working in AIG. Prior to this, I was working in a company called Xerox, where we were trying to implement a simulation technology across hundreds of print shops. And they're clearly building something like this. The processes were different clearly from insurance and some of these and finance and investment processes, but you have a lot of scale. So you build once and you have many instances where it can be utilized, right? So clearly there is a huge benefit. Now, if you have one instance and there are only 5 other instances of a business process, you have to make that trade-off, right? Whether it's worth creating a solution or just doing it 5 times using like the manual method or how typically it's done. So it really depends on a situation to situation.
Well, thank you very much. Great questions, great presentations. Very much appreciate you you being here today. It was very informative. And we almost took up your full half hour, but again, thank you very much. Let's take a 4-minute break. Stretch your legs. We'll be back in a few with the next presentation.